Dynamic navigation for higher performance. Reducing or removing navigation code from the GUI by adding derived links and, at the same time, improving performance. Modeling class structures takes some thinking, and when done the thinking and the drawing and after that starting up using the model, then you'll spend awful lots of code traversing links in order to retrieve trivial info in a given object structure. Navigating the same sometimes complicated link paths over and over again takes CPU power, and it also takes much redundant code and / or expressions accessing the same navigation paths over and over again. In the bold architecture you would also place redundant subscriptions from many different locations to the same target subscribing to the same paths, over and over again. But with bold you can often directly address unnecessary navigation, the redundant navigational code / expressions and gain decrease of CPU load by adding derived associations instead, making the few persistent links more useful and intelligent. And furthermore, doing this directly in your model will at the same time reflect more specifically which parts of the model is actually used and how. An example can show a typical situation where adding many derived links, extending the model with more useful info, will result in more efficient, less redundant, and more readable code. If we were talking traditional handcrafting, you probably would have thought I was joking, because we usually don't save us from more problems by adding more relations between objects. But I'm not joking. You will actually achieve all the mentioned benefits by adding a few simple lines to the model using bold. Example: a truck-vehicle combination can serve us with an example. The example model will consist of vehicle units, some parcels and a trip object keeping all the trip info and calculations. With these three basic categories we will end up writing almost 50% of code, or expressions, in algorithms navigating the basic structure which has only 3 persistent links. Such coding is trivial, takes time and adds nothing of value to the system. First, a real-world representation of the example before representing it using an UML class diagram. Real is my initials, Fig 1. This vehicle combination contains of parcels, but only the frontmost vehicle unit keeps trip info about distances, events, and economic calculations. Disregard the arts aspects of the illustration. For several reasons, not discussed here, the vehicle units shown above always has a trip object attached, but only the frontmost trip object is representing the entire combination. The other trip objects / calculators are demobilized until the trailer, possibly, is disconnected from the truck, and then the trailer will be a valid, frontmost, trip holder on its own. Imagine you are viewing one of the vehicle units or one of the parcels in a UI and you would probably like to know more about trip-related info, perhaps distances traveled, addresses visited, the visiting order, costs, or revenues per km etc., all administered by the trip object. There are only 3 relations in this model, but still you would have to think twice when trying to navigate correctly, trying to find a calculator, here representing a trip class. It would be even worse if you want to implement some generic logic or calculations for the vehicle units, because you would always have to make sure that you navigate to the frontmost vehicle unit, let's call it the hauler, and from there navigate directly to the trip info, the calculator. In the real application there is so much info embedded in this basic structure that the 3 links would be accessed/navigated again and again so many times that many hundreds of lines of code, and / or OCL expressions, would be written here, there, and everywhere. One of the bad things with this is that if you explicitly traverse these links every time you need to access an object/attribute in the other end of the structure, you will need to execute this logic in the CPU every time. Another bad thing is that your core business logic would drown in the code and the expressions dealing with this trivial navigation, like if then else, for I equals and assign checks. This is where derived links can help a lot to avoid a logical mess. Derived attributes would too, of course. Fig 2. A simple class model of the illustration above could look something like this. The navigation problem is more obvious in this class model than in the real-world illustration. If I selected a parcel in a GUI list and needed info from the trip object, I couldn't be sure of the exact navigation path to the mobilized trip object, which is the one holding the valid trip info. Example: if the parcel was loaded on a trailer, the expression vehicle_unit.trip would return a demobilized trip object, but if the parcel was loaded on the hauler, it would return the desired mobilized trip object. This complication is reason enough to add a derived link fixing the problem directly in the model so that one never again would have to consider this when designing algorithms or navigating the structure. I would definitely add a link called effective trip as follows. Fig 3. A link called effective trip was added to the model. I always try to let blue color represent persistent, equals freeze, and orange representing derived for links. As I already can foresee that this link will be accessed for numerous vehicle combinations, in grids etc., I would hard-code the derivation optimizing the logic here to find the frontmost vehicle, and that means traversing the trailer/hauler link and stop when the hauler link is nil, equals is frontmost. From there we can reference the trip object directly. But I also know that finding the frontmost vehicle, the combination hauler, is very typical and will happen even more often than accessing the trip object itself. I already know that the effective trip link as well can use such a derived link. Let's add it right away, giving it the name combination first. I choose the name combination first because then you immediately realize the typical in this situation. It's a typical list handling problem. You can already imagine the usefulness of another derived link, which we can call combination last, and even a third link called combination units. I can assure that these links will be frequently used, and thus the cost of evaluating them will be paid off already the second time you use any one of them. Fig 4, doesn't also derived links require CPU in order to be evaluated? You might ask. The answer is, yes, of course, but only once, if the subscribed items don't change. And this is not very likely here, but the very hotspot structure here will be used in many places in the logic. Accessing objects crossover very often, and when doing so the links already directly references the instances you want to access. Look at the mess below. This a high-performance solution using the model as the tool for optimization, and at the same time the additional links are clarifying/indicating directly in the model the intended usage of this specific structure. For those of you who think that I finally got mad, I can tell that I didn't. Instead, I increased the speed of the calculations and all the activities related to this structure in a real-world application with many 1000% compared to explicitly defining the entire navigation path each time the combination trip or a specific vehicle unit, or attribute in any of them, was accessed. All kinds of data are stored in this structure, and more than 30 derived attributes for different calculation purposes accesses the structure back and forth all the time, providing the client user with real-time calculations of revenues/km and distances, distance shares of totals, share of shares of, etc., etc. The thing is to let one derived link use the other links as often as possible, then even the need for re-evaluating the links when things changes decreases. The last statement can be verified very clearly with a separate example showing how important it is to reuse everything you derive to every higher level, regarding which part of the structure is more likely to change and which part is more static. With reuse I mean the CPU work already done in deriving the link. More on this could be subject for a separate article. Now look at the code. We need to get hold of the trip object, for some reason, starting from a parcel, but we don't know on which vehicle unit we are loaded, so we start looking for it using the link effective trip, which hides the logic determining which trip object is mobilized. I.e effective function t parcel dot calculate e trip underscore something double var trip obj t trip begin trip obj equals vehicle unit dot effective trip / that's it. Easy. This is clear code. The details about how we got hold of the correct trip object should not be mixing up the business logic dealing with access or calculations in the object structure. In our real-world application, both vehicle units and parcels have a common superclass, not shown here. A vehicle can be loaded on another vehicle, just like any other parcel, so the code above is even simpler in my final generic model, where the derived link is virtual overridden in different subclasses. My final code goes like this: begin trip obj equals effective trip / that's it. The parcel will find its valid trip using this command, regardless of how complicated the path might be. This is shown in Fig 5, where a new common superclass actually owns the persistent and derived link to the trip class, and the effective trip link is implemented first in the T parcel and then overridden for the vehicle unit class as shown below. Fig 5. Here I modified the model to become more generic, allowing any planable object to carry a batch of other planable objects, and as the model goes more generic, the role names do so too. Trip info applies directly for a parcel too, via abstract plan portion, because a transport company can plan a parcel to be delivered with, for instance, an aeroplane, which totals we are not interested of, but we are still interested in keeping track of any trip events involved in the actual transportation, and documentation, and transactions attached to the parcel itself, etc. But this also means that when there's need for accessing the effective trip object, we also do need to perform very complicated checks all over the structure, trying to find out in which context the correct mobilized trip object can be found. This will really make our logic somewhat complicated for such a simple thing as simply retrieving some data from the structure. A real nightmare, in fact. This complication of a simple thing is not very unique. What is unique is how it can be dealt with using bold technology with its derived links. The parcel can be the trip holder itself, or if the parcel is loaded on a carrier, it don't know if it's loaded on the carrier which actually holds the trip info. We would really need to do some navigation here. In a situation like this, you can easily imagine how much coding and how complicated OCL expressions would be accessing information in the structure. Your core business logic would drown in navigation logics when simply retrieving trivial things from the structure, and the CPU would spend lots of time finding your way to the target object/data. Finally, 3. Persistent links holding the structure all together ended up in another 5 very useful derived links. The result is that the final application runs much faster and business logic is held more apart from trivial navigation endlessly traversing object structures. Before listing the most efficient code for the optimized hard-coded derivations of the links, I would like to conclude that with these links you can, from anywhere in the structure, go anywhere, directly, by referencing link members with names fully clarifying what you intend to access, and this will be done in the most efficient way you can come up with using the regular bold architecture. With efficient I mean always direct access to the desired target object instance, except for the first evaluation, which in my case happens only once for hundreds of accesses. This is only part of the concepts we used consciously to make possible what was not possible before, using regular, but clean design, modeled and structured object-oriented business classes performing high-performance real-time, calculations of very advanced trip calculations, not discussed here. On a single CPU, application server, for multiple clients. Derivation code. With comments in the code below, I underlined all the internal referencing of the derived links, efficient reuse of already evaluated results. I also used local variables, thus avoiding the internal lookup of bold members more than once, avoiding repeated triggering of internal bold events, etc. The efficiency of the entire concept discussed and the detailed coding below is verified using ProDelphi Profiler, very high accuracy, +3%, on measuring code performance. T-parcel procedure T-parcel_effective _derive and subscribe / if loaded the carriers, effective, trip is returned, / else the local trip, if any. Var carrier obj, T vehicle unit, result value, T trip, begin m_batch holder default subscribe, subscriber, resubscribe, carrier obj equals batch holder, if assigned, carrier obj, then begin carrier obj.m_effective trip.default subscribe, subscriber, resubscribe, result value equals carrier obj.effective trip, and else begin m underscore trip dot default subscribe, subscriber, resubscribe, result value equals trip, and m underscore effective a trip dot bold object equals result value, and t vehicle unit procedure t vehicle unit underscore effective a trip underscore derive and subscribe var holarog j t vehicle unit result value tripog j t trip begin result value equals nil m underscore combination first dot default subscribe, subscriber, resubscribe, holarog j equals combination first, / the traversing is already done here if assigned, holarog j, then begin holarog j dot m underscore trip dot default subscribe, subscriber, resubscribe, tripog j equals holarog j dot trip, if assigned, tripog j, then begin tripog j dot m underscore is mobilized dot default subscribe, subscriber, if tripog j dot is mobilized then result value equals tripog j, and m underscore effective a trip dot bold object equals result value, and procedure t vehicle unit underscore combination first underscore derive and subscribe, / this link will be the fast shortcut used by many / functions in the scope and other links and attributes, the / meaning optimization, not extras or candy in the model. Var loopog j, t vehicle unit, begin loopog j equals self, / traverse ahead loopog j dot m underscore holler dot default subscribe, subscriber, resubscribe, while assigned, loopog j dot holler, do begin loopog j equals loopog j dot holler, loopog j dot m underscore holler dot default subscribe, subscriber, resubscribe, and m underscore combination first dot bold object equals loopog j, and procedure t vehicle unit underscore combination last underscore derive and subscribe, derived object, t object, subscriber, t bold subscriber, var loopog j, t vehicle unit, begin loopog j equals self, loopog j dot m underscore trailer dot default subscribe, subscriber, resubscribe, while assigned, loopog j dot trailer, do begin loopog j equals loopog j dot trailer, loopog j dot m underscore trailer dot default subscribe, subscriber, resubscribe, and m underscore combination last dot bold object equals loopog j, and procedure t vehicle unit dot combination units underscore derive and subscribe, var loopog j, t vehicle unit, result list, t bold object list, begin m_combination units dot clear, result list equals t bold object list dot create, try m_combination first dot default subscriber brewery subscribe, loopobj equals combination first, repeat result list dot add, loopobj dot m_trailer dot default subscriber brewery subscribe, loopobj equals loopobj dot trailer, until loopobj equals nil. Finally m_combination units dot add list, result list, free and nil, result list, and procedure t vehicle unit underscore combination loadedms underscore derive and subscribe, derived object, t object, subscriber, t bold subscriber, / a list collecting all, batch, items loaded on any unit in the / vehicle combination. Implemented for convenience and / clarification. Var unit cnt, I, integer, unitobj, t vehicle unit, begin m_combination loadedms dot clear, combination units dot default subscriber, brewery subscribe, unit cnt equals combination units dot count. If unit cnt 0 then begin for I equals 0 to unit cnt 1 do begin unitobj equals combination units I, unitobj dot loaded items dot ensure objects, unitobj dot loaded items dot default subscriber, / collect all. If unitobj dot loaded items dot count 0 then m_combination loadedms dot add list, unitobj dot loaded items, and / Rolf Lampe. Current mail address, rolf.lampe@trilnet.com